13, the equation 24x squared plus 25x minus 47 divided by ax minus 2 equals minus 8x minus 3 minus 53 over 8x minus 2. So this is essentially testing our ability to divide polynomials or calculate rational expressions. So what do we have here? I could look at this and look at polynomial long division or synthetic division, or I could note that my remainder is minus 53 and use my remainder or factor theorem. That's going to be difficult because I'm actually plugging in what would be c. You know, if it's over x minus c, the remainder theorem says polynomial x over x minus c. C in this case would be 2 over a. I'd have to plug in to get minus 53. That's going to be a little tricky just because I'm going to be plugging in a variable into the expression. I'm going to use polynomial long division between the different options. So if I set that up, I know ax minus 2 divided into the numerator polynomial 24x squared plus 25x minus 47 equals minus 8x minus 3 minus my remainder. I'm just going to call it the remainder. What I have to have here is minus 8x times ax equals 24. So, in other words, I have to have 24x squared in my polynomial long division to subtract that and cancel it out to be 0. So that means minus 8 times a, the two coefficients of x's that make the x squared term, must equal the 24, the positive 24 here. That means a equals 24 over minus 8. A equals minus 3. I think that's the easiest way to calculate this. The answer for 13 is B, minus 3. 14. What are the solutions to 3x squared plus 12x plus 6? So right away I'm going to try and pull out a common factor. 3x squared plus 4x plus 2 equals 0. And I want to find the solutions or the roots here. So I want some factors. It's a simple case where my leading coefficient is 1. I want the factors of 2 that have a sum or difference of 4. Okay? Well, that's not going to factor. In fact, if I look through the answer choices, I should have known that, right? Because all my answers are irrational roots. So I'm not going to be able to factor this over the integers. So what I can do is immediately go to my quadratic formula. X equals minus b over 2a plus or minus, and I'll write them as separate terms, b squared minus 4ac over 2a, and that works out to minus 4 over 2 times 1 plus or minus 4, that's the b squared, which is 16, minus 1. Sorry, 4 times 1 times 2. Okay, all over 2a, which again is 2. So what does that work out to? It's minus 2. Right away, these are wrong. Plus or minus 16 minus 8, which is the square root of 8 over 2. Now I can rewrite the square root of 8 as square root of 2 times 2 times the square root of 2, which is just simply 2 root 2. So I'll rewrite this as minus 2 plus or minus 2 root 2 over 2. Those 2's cancel. The final answer here for 14 is minus 2 plus or minus root 2. The correct answer for 14 is A. Okay. C equals 5/9 F minus 32. Can right away recognize this is a Fahrenheit Celsius conversion equation. Based on the equation, which of the following must be true? So one thing we want to know is we want to know the changes, because we're all the answers in our Roman numeral question are talking about increase, 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 which is essentially a change. So change in C equals 5/9 times a change in F. That's usually the easiest way to do it. And then when I distribute 5/9 times 32, well, the change in 5/9 times 32, in other words, the change in a numerical constant, is 0. So really, change in Celsius equals 5/9 change in Fahrenheit, okay? If I have a 1 degree Fahrenheit, that's going to be equivalent to a temperature change of +1 times 5/9, which equals plus 5/9 Celsius. So an increase of 1 degree Fahrenheit is equivalent to an increase of 5/9 Celsius. Number 1 is true. Okay. Number 2, a temperature increase of 1 degree Celsius. So if I said +1 is my change in Celsius, then my Fahrenheit is going to be 5/9 times delta F. For that to be 1, delta F has to equal 9/5, the reciprocal of 5/9. Only then 5/9 times 9/5 equals 1. So a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 9/5, or in decimal form, 1.8 degrees Fahrenheit. That is correct. Again, our Fahrenheit change is a greater number than our Celsius change. That makes common sense. Number 3, a temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. Right here we know this is wrong. The Celsius change is not a greater number than the Fahrenheit change. That cannot be correct. So 3 is incorrect. The correct answer for number 15 is D, 1 and 2 only.